Good morning. It appears my iPad decided to do updates, so I'm going to have to wait a few minutes, okay? Because, well, let's see if I can open this. I'm doing updates involuntarily. I hope everybody's doing great. I sent out the syllabus just now with the official prontuario, so you have that for reference, and I've included in the syllabus the chapters from the textbook that you could review as reference, but primarily it's going to be my notes that you're going to focus on. So some people wrote me and they asked for tips. My strongest recommendation is that you stick with the notes. If you have extra time, other than doing the notes and the exercises I give you, if you have extra time, let me know and I can give you more material. But I think you have more than enough coming. And if you need extra help, please let me know and I can meet with you individually or in groups online. All right, so we left off here with NPV. We talked about mixed cash flows, and I showed you how to use the NPV function and the formula to solve a valuation problem for an investment. So you price out the value of these returns. And that was the formula we left off with. No, we did perpetuity as well. That's right, we did perpetuities. And that's right, we did quite a bit, but we still have more to go. So we talked about, perpetuity. That's the perpetuity formula. And I mentioned that there's no formula programmed in your calculator, you just have to compute that yourself. So in a situation where you have exactly this set of cash flows, what is this? This is, you're being asked for the value today or now for cash flows that are the same to be received beginning one period from now. So all you really need, since they're the same, is just the first one. That's why you have a one subscript here. And I explained to you, I rationalized, and if you didn't see that, go back and watch the video. I rationalized where this formula comes from. Very important that you understand where these come from, so you're more comfortable with the formulas in general. Then I talked about what if they're not level per se, but they're not mixed either. There's a relationship between the cash flows, future cash flows. In this case, the relationship is they grow at 2%, and the growth rate looks like it's like an accumulation rate, right? But in this case, it's a rate of growth. And so this cash flow, the second one, is higher than this one by 2%. And then the third one is higher by another factor of 2%. So factors accumulate with a higher power, and this will go on forever. So this is a situation of a growing annuity with a growing perpetuity. So a growing perpetuity, since we don't want to use the NPV formula and forever enter values, instead we modify the formula that we already have for a perpetuity. And what is the idea? The idea is the cash flows, the rate of the growth of the cash flows to come offsets the effect of the erosion of future dollars by the interest rate. So that's why that is going to be the formula we're going to use, with the condition you only apply this formula if the interest rate exceeds the growth rate. If it's the reverse, I explained to you, you don't use this formula. If the growth rate is so great, greater than the interest rate or the rate that you're going to use for the time value of money, then this formula does not apply, and actually your cash flows will explode, and what you're holding is worth, what you're looking at is an infinite amount of future cash flows. or the value is an infinite amount, which we say in efficient markets won't exist. So I applied it there, and that was it. So this is where we left off. If you have any questions, you could put it in the chat. Most of you are here. It's great. I see 26 people watching. As I explained, you don't have to attend the lectures, but if you miss one, watch it right away, because I'm going to continue as though you've seen the previous lectures, and they will pile up if you don't watch them right away. So we left off here. What if we don't have a mixed cash flows case where the cash flows are different, the cash flows to be received or paid are different. Instead, they're actually the same. So back to the idea that they're the same. However, they're not infinite. What if they stop? So we know this. We know this timeline. This timeline, in this case, this example above, is $100 to be received every month at the end of the month, we assume. And I want the value of those. Okay, so you could use your NPV function in the calculator and enter them 48 times, or maybe you use the frequency button, right? And you say, well, there's 48 months. It's for 4 years. So you could use that frequency button and get a calculation. But I don't want you to do that, all right? What I want you to do is realize and learn these formula and properly use your TVM row. I'm stressing that because I'm going to give you much more complex problems, and I'm going to assume that you can do these components quite efficiently using the calculator, all right? So what is this situation? Okay, so I'm going to derive the annuity formula. Maybe you've seen this, maybe you haven't, but I would really like you to understand it, because understanding this will help you solve problems that aren't exactly, problems that don't exactly apply to the annuity scenario, but allow you to modify the annuity formula to suit your scenario. Someone just asked, where's the rate of return in the timeline? It's just in between. I didn't draw it on there. But so in this case, it's 1%. So the rate of return is just in between on the timeline. Can you see that? We don't put it on the timeline, okay? The only rate that we might put on the timeline is the growth rate, is a growth rate. So let's look here. So this is, in general, what you're looking at. An annuity, let me lower this. So let's look here. So this is an annuity. Sorry, this is a perpetuity. So where does an annuity come from? An annuity comes from so these are the conditions of an annuity, that you have level cash flow, so C1 is the first one, and then they're all the same as that one. So I use the notation C1, C1, C1. And then it stops, right, at period T. That's how the formula works. That would be an annuity. What would be a perpetuity would be that it went on forever with the same level, and this would be the formula. Using that notion and introducing the technique that I show you, we can derive the annuity formula. The cash flows that come after T in an annuity don't exist, but in a perpetuity they would be here. We would have to take them off, take them away, subtract them from the perpetuity to get our annuity formula, and that's exactly what the annuity formula is. Okay, so this is just the same thing as these, just continuing forever. So this is also a perpetuity. However, the perpetuity begins at T, not at 0, like here. So notice, this is just the perpetuity formula, but what did I change? I changed this, okay, the subscript, to remind myself that I cannot add or manipulate this amount and this amount. So what I need to do is take this amount, use the basic time value of money concept. So this represents all of these cash flows, right? So I don't have to look here anymore. It's all of that is represented just by this formula. And now I'm going to discount that. I'm going to pull it back to time 0. I'm going to label it B, like part 2 or part B. I'm going to label the entire perpetuity part A. And what I want to do is I want to subtract this from the whole perpetuity. And that's where the annuity formula comes from. Watch here. I'm going to take the A part, the perpetuity, and subtract off the present value of the future perpetuity. And that's where that formula comes from. So let me let you stare at that for a little bit. You've seen this formula before. You used this formula in 3106. Some of you may have forgotten it because you took it a while ago. But that's it, and that's where it comes from. It's a perpetuity, so you can think of it as a perpetuity with an adjustment, this factor of adjustment. Okay, so if you've used tables in 3106 with other professors, that's fine. You can still conceive where this comes from. But I hope you appreciate the efficiency of entering this into the calculator. I'm going to show you how to do that with a particular exercise. So the calculator has this programmed. This formula is programmed in the calculator, and we're going to use it. So this formula applies specifically and only to this stream of cash flows. What are they? The same cash flow, with the first one starting 1 period from now. All the rest are the identical cash flow up until time t. That timeline corresponds to that formula. So let's apply it. Okay, so here's the problem. You obtain a loan to help you make monthly car payments of $100 for the next 4 years. The effective monthly rate of interest is 1%. So you have a 1% rate within the periods. I draw a timeline, so you have to get into the habit of this right off the bat. Identify the timing of payments, and that will determine how you draw the timeline. Payments here are monthly. Monthly payments, okay? So that means my timeline is by month. I have $100 each month, and I'm told that the effective monthly rate is 1%. Now that's really important. This word effective, we're gonna spend some time when we finish these sets of notes. We're going to go right into interest rates and interest rate conversions, and it's the effective monthly rate that are used in our formula. Okay, if you don't have an effective monthly rate, you got to figure out how to get it. So we have everything we need. 1% rate in the month, and we're going to apply this formula. So what do I put? So C1, remember it's the perpetuity, so the 100 here with the interest rate, and then this adjustment amount. So it's 1% here, and then 48. So this will get you points on your exam, but nothing else except for the timeline. I want the timeline, and I want the formula with the values inside and the result. Now, how do I get the result with my financial calculator? From left to right, you're going to enter all the variables, all the values, right? So I'm going to show you how to do that here. This is the formula with the values inside. So n is 48, because remember, n is the number of periods, or the duration of the investment. The interest rate is 1. Remember, we put in the percentage value. PV we don't have, but we want to get it. We are going to make a payment of $100 in the storyline, so that's going to be negative, remember? And then we're going to not need the future value. So this is different than what we did last class in that we're looking for the present value of payments. So this is the first time I introduce you to the payments, all right? So be aware we're finally using this. And then the future value, we have to put a place mark. We're not going to use that for now. Put a 0 in there. Okay, so you enter all the values, and then you ask to compute the present value of that. So the amount is $3,797.40. Okay, let me give you some time to try that. Punch that all in, and we'll discuss it. I sent you some problems, some exercises to try. Today I'll send you the solutions, and I'll send a new exercise as well, right? So you keep on working. I should also probably give you the Connect assignment today, or the worst early tomorrow morning. Okay, any questions? So now we have payments. This is different than just than the timelines we've been working with. We'd worked with initially, where there was just one lump sum that we were looking at. We're looking at several payments over time now. Okay. Continue. Let me look at the exercise first, and then I'll go back to the formula. I'm going to page 49, if you're following in your notes that I sent. How is this problem different than the one that we just did? Can someone tell me? You sign a 5-year lease to rent your office space to a dentist for $1,200 per month to be received at the beginning, I underline it, of every month for 5 years. The effective monthly interest rate you agreed to is 1%. What is this deal worth to you today? So this is different. How is this different? Anyone? If we have time, Luis, we will discuss the homework exercises. I'm going to send the solutions first, and then you guys can ask me if you have problems with the homework, okay? So I'll give you the written out solutions. You have a chance to think about it before I spend time solving them. So what's the difference between this and the one that we just did? Right, so we do not assume it's at the end. I tell you it's at the beginning. Perfect answer, Brenda. And so that shifts the timeline over. It shifts, even though there's 60 payments, they start now and they go to 59. So how does that affect our formula? How does that affect our formula? How do we deal with that? Because our formula isn't sufficient, is it? The formula does not apply to this timeline. So you have some options. I'm going to go through the 3 options. Well, there's 2. but 3 methods. So let's see. Isn't it the case that if I just look at these cash flows, that's an annuity, right? Because that starts 1 period from today and goes 459. So this part is an annuity, except I'm missing this one. So why don't I just make this an annuity with 1 less and add back the 1 today? So I am manipulating the annuity formula in this way, although this is the way you could write it in a long form. I prefer that you use the what I call the annuity due formula. So this is the annuity due formula. Okay, annuity due up front. Due means now, I guess. Annuity, they also call it an advance. Annuity in advance. So it's going to pay you sooner because you're going to get 1 now and then you're going to get 59. So you're going to put that adjustment, that's one piece of the adjustment, and then this is the other piece of the adjustment. And that is the annuity due or annuity in advance formula. Okay? And then the question becomes, how do I enter that into my calculator? So that's the formula, one formula. In terms of the problem, let's look at the particular problem. This is what I would write. Okay, so there is the 1 less, so 60 payments, but the first one now, and then the rest here with the regular annuity formula. And that's how you could enter it. You could enter it as an annuity with 59 and add 1. That's one way. So I call that method 1. So why don't you take a moment and punch that in and see that you get my answer. So make sure you get my answer. Let me know if you don't get it. So keeping in mind, what we're doing is using the annuity keys to compute the 59 payments. Be careful to make sure that you change the sign of your screen before you add in the initial payment of 2,000. Oh, sorry, 1,200. No questions? Okay. No questions? No questions? Everyone gets it? If you didn't get it, make sure that you are adding, putting a positive sign on this result and then adding in the 1,200. So that's method 1. Adjusting the formula to the annuity in advance or annuity due formula, and then using your calculator to get the second half, second part, and then adding in the first. There's a second method. Why don't you just use the begin mode? Remember, I taught you how to set it up in begin mode. These are the settings. I'm sorry, these are the keys you punch. You hit second, begin, second set, and now you'll see, if you clear the screen on the top, there's going to be the begin symbol. So it's warning you, because it has to be a warning. You need to know, you need to be sure what the assumption is of your calculator. So if it's in begin mode, then all you have to do is enter the values as you would normally, and the calculator does the adjustment for you. So you enter normally as though they were payments at the end of the period when we started, and then the calculator will use the begin formula instead, the annuity due formula instead. So that might be the easiest way, but don't forget to return your calculator to end mode, or the rest of your assignment or the rest of your test will be wrong. Or working through assignment with solutions, you'll be tearing your hair out not knowing why you're getting the wrong answer. Look up on the screen, make sure that begin is only there when you're solving a problem with an annuity in advance. So that I refer to as method 2. So make sure you can get that. So notice I keep saying opportunity cost, right? Because what I'm doing is trying to figure out the value of renting the space out. And I compare that against maybe selling. Maybe someone's offering me $50,000 and I say, no, you know what? I'm going to hold on to my property and rent it out because it's worth $54,485.51. Okay, so your value should be not close, it should be exact. Okay, so this is important. When you don't get the exact values, you're doing something wrong. So let's see. For which one is that, Alfonso? For this, which problem? The method 2 method or method 1? The delay here is tremendous. I don't know how to make the feed go faster. I'm just waiting to hear back from Alfonso. So if you put the values here, no, something is wrong. Make sure you have exactly what I've done here with 59. You're getting a little bit... Alfonso, that's not right. You should be getting exactly my numbers. You're getting higher. You're getting higher. You sure you're putting 1,200? You sure you're putting 59? Not 60? Should be 59, not 60. Let us know if you've sorted out. How's everybody else doing? So many of you. Only one person with trouble? Okay, let's continue, and then if it continues, Alfonso, we'll talk about it after class, okay? I'll let everyone off the stream and we'll talk. So the third method is important as well. Okay, so they all have their purpose. You need to know all three methods. All right. You need to know all three methods. These are techniques that you will use in solving a variety of problems. As I mentioned yesterday, the timeline does go beyond 0. It can go into the past. So here I've drawn the timeline with that idea. By doing this, by making this extension into the past, now I see an annuity, a regular annuity, with the first payment 1 period from today, not from today, sorry, with the first payment 1 period from last month, in other words today, and continuing up until 59 months from today. The total happens to be 60 payments, but it would begin today from the perspective of last month. This approach generates a second formula. Here's the second formula. It's this one here. Okay, so you might see this one when I solve problems. What it's doing is using the regular annuity formula, shifting it back, because that's what the annuity is. It's shifted up, it's shifted back. Those are the same thing, but the shifted earlier, right? Immediately. And then you have to make this adjustment of the amount to be at time 0. Now, if you use this method, you should get the same answer still. So what does that involve in terms of the calculator? It involves entering into the calculator as though you have 60 payments, but remembering your result is 1 period back. So now I see Alfonso's answer. So what he did was, yes, he used 60. So if you use 60, you're going to get Alfonso's answer. But that's wrong because it's not 60. It's actually 59 starting today. Or 59 starting 1 period from now plus today's. So that was your mistake, Alfonso. You were putting 60. It was supposed to be 59. Anyway, so in this exercise, you're going to use the regular annuity, and then you're going to adjust the regular annuity, shifting the answer to the correct answer. It's $54,485.51. So I hope I've resolved the problems there. If you didn't get any of that, I'm going to send you an exercise so you can practice today. But let me finish these notes, all right? So if you feel like you're not grasping it all, that's fine. That's how you should feel, because this is a learning process. You're going to learn something new, all right? You're going to review, you're going to practice, and you're going to get it. So these are the 3 methods. I will refer to them as the 3 methods for solving annuity problems, and that brings us to bonds. All right, make sure your calculator is back in end mode. There should be nothing on the top of your screen. And we're going to move to bonds. I will share with you some annuity exercises by email that you can work on today. So bonds. What we've done so far is covered the NPV, mixed cash flows using NPV, and then we discuss simplifying cash flow streams that have some sort of pattern using perpetuity formulas when the cash flows are the same and infinite, or growing at the same rate infinitely, and annuities for cash flows that are finite but are related. Actually, I have the bond stuff here. I think I have the growing annuities later. Okay, maybe it's out of order, but okay, let's do bonds now. So notice my formulas are all the same. I'm going to use the same formulas, even in applications for bonds and stocks. We've already valued stock in our exercises. All right. The thing that's going to change is the way that I refer to the rate of return, or the interest rate. In bonds, we speak of the relevant interest rate as the yield to maturity. Okay, so just the terminology changes. When it comes to bonds, we're going to talk about the yield to maturity, but that's just the interest rate. Okay, that's the interest rate for valuation. So if bonds of comparable risk have a yield to maturity of 6%, so this is rationalizing why I picked 6%, because bonds that are similarly risky have a yield to maturity, have a return of 6%. So I can figure out the fair price based on that. So this is the timeline for bonds. So what does it look like? Which timeline does it correspond to? In this case, this is a pure discount bond. So you just do pure discounting. You're going to apply the basic time value of money formula. You're going to apply the basic time value of money formula to determining what's it worth for you to spend today to be promised $1,000 later. Okay, that's what a bond is. It's a loan. If you purchase a bond, you're loaning some money with the commitment of the bond seller to give you $1,000 later. In this case, 5 years from now. So those are the terms for the bond. Thinking about it, it's just the regular time value of money formula solving for the present value. The future value is 1,000, or now we call it the face value of the bond, right? Face value. See how convenient the notation is. Future value and face value are the same thing in the same acronym, FV. And I'm going to discount it at the rate that I'm going to use for the return of 6%. And I determine the price that way, or the present value. So what is it worth? I'm not willing to pay any more than $747.26. How did I figure that out? Well, you might have punched it in your calculator the hard way, or use financial keys, which I really want you to use and be comfortable with. Okay, each time I would teach the calculator with the 3106 group, more than half of the students resisted using the calculator until they realized how efficient, time-saving, and easy it was. So, you still need to know how to punch this in, okay? I still expect you to know how to punch that in. But we don't have to do that all the time. So from left to right, enter 5 periods, 6 as your rate. PV is what we want, so don't enter it. There are no payments. We're back to no payments, right? There's no payments. It's just a regular time value of money problem. And the face value or the future value to be received is a positive 1,000. compute the present value, and it tells you the answer is it's worth $747.26. That's the most you're willing to pay to get $1,000 later. Any questions? So that's a bond problem with an application of the basic time value of money formula. So that was discount bonds. Discount bonds were the same as a loan. That you've loaned your money out and you get it back with interest, or you're getting it back with a yield to maturity of 6% in the last exercise. But what if it's slightly different? Bonds actually pay, there are bonds that actually pay coupons. These are payments of a specified amount. In this case, you're told 6% coupon bond, now what does that mean? Pays $1,000 in 5 years. So this is the discount bond portion. So you're getting the $1,000 back. You're getting $1,000 in a year, but you're also going to get 6%. 6% of what? Well, to figure it out, you're taking the rate. This is the coupon rate. You calculate the payments you're going to receive, and you can put them on your timeline. So the payments are computed as 6% of the face value. So 6% of 1,000 is 60. All right? So that's $60, and you're going to get that at the end. We assume, remember, we assume that unless it tells us otherwise. $60 at the end. And then at the very end of the term of the bond, 5 years, you're also going to get the $1,000. So this is a bond with 5 years to maturity that pays $60 at the end of every period. What does this look like in terms of the formulas on your formula sheet? Is it one of the formulas on your formula sheet? The formula sheet I sent you. Anyone recognize? What we have here is this part looks like an annuity because it's a finite set of cash flows beginning one period from now and that end at 5. So there's the annuity part, but then there's this part too. So I have an annuity and I have a basic time value of money portion. So there's two parts to the formula for coupon bonds. And those two parts will actually force you to use all the keys. This is the first time we're going to enter values into all of the keys of the time value of money row of the calculator. Okay, so for coupon bonds, you use all of the keys, and I'm going to show you how. So first, let's look at the formula. The formula is two parts. Two parts, the annuity part, and then the basic time value of money part, the discounted portion. That's it. So don't forget the two parts. You have to write this up. You have to, on the exam, you have to write that the whole thing up. And I'm going to talk about the point of it in a second, but first, let's enter it. Let's enter it. So how do you enter it? You use every single key. 5 into the time, or the number of periods, 6 into the interest rate. PV is what we want. So now we're going to be receiving $60 payment and $1,000 at the end, future value, face value. Compute the price and you get 1,000. So what does this mean? First I'll let you enter it and I'll discuss it. Everyone's got that? So now think a little about your result. You're going to pay 1,000 if you were looking at buying this bond. You're going to pay 1,000 to receive 1,000 in 5 periods. So you're spending 1,000, so it ends up that this costs 1,000. To get 1,000. The only reason this is worth it is because you're going to get 6% coupons. In other words, $60. So you're getting your interest through your coupon payment every period, and then you get your $1,000 back. So that's how you loan them. That's what you're getting for loaning the money. So it's 1,000 to get 1,000, but you get paid interest, the interest payments over the period. This kind of a setup is called a par value bond. Okay? And it works out this way because it happens that the coupon rate and the interest rate, so the coupon rate is like C, and the interest rate are the same. They're both 6%, notice. If you don't get your yield or your interest through the coupon, the price is going to be different. Okay, so if you get more than the interest through your coupon, you should pay more for that. If you get less than the interest in your coupons, you should pay less for that. And that's what we're going to talk about next. This is always the formulas you need. You need the timeline, and you need to know how to punch this in to your calculator in the financial keys. Okay, so here's an example as I explained. So this is the example where this is slide 62. Your coupon now has a rate of 3%. So that's less than the yield to maturity. So you're only going to get $30, not the full yield through the coupon payment. So you need to be compensated for that, right? The compensation will result in, so you're going to have 30, 30, 30, 30, and 30 all the way to the end. That's your annuity piece. And then your lump sum or your face value at the end. So this is not going to be worth $1,000. This is worth less. There's the formula you have to write up with all the values inside. The cash flow, in other words, the payments will be 30. That's the annuity for 5 periods. And then the face value of 1,000 at the end. We call this, because it's less than 1,000, this is known as a discount bond. And it happens to be less than 1,000 because the coupons are not going to pay you your interest. So you need to pay less for that. Okay. because you're going to get 1,000 at the end. So usually bonds in general have face values of about $5,000, $1,000, $5,000. So we're going to, in our exercises mostly, I don't know about the textbook because I haven't read every exercise in the textbook, but in our problems we use a face value of 1,000. So entering that in to confirm, here are the values. I'll give you some time to punch that in. Five periods, 6 is the interest. The payment is what we need, so we do that after. Sorry, the payment is 30, and the future value is 1,000. So we receive these are positives, and we ask to compute PV, and we get that result, 873.63, which represents the price value, the most you'd be willing to pay to get that deal. The final example I'm going to give for now. What if the coupon rate is higher than the yield to maturity, or the implicit interest rate of return? If it's higher, it's $70 instead of the $60 for a par value bond. Well, you should pay more than 1,000 to get that deal, because you're getting more than the yield to maturity through coupons. And that's exactly what happens. I set it up with the formula. The two parts. This is the annuity piece. This is the basic time value of money lump sum payment at the end. We call this a premium bond because the coupon rate is higher than the yield to maturity, or the interest rate for the formula. And when I punch that in the calculator, I find exactly what I expected. It's more than $1,000. Again, this is a review, so you should know this, but if anything, I'm teaching you how to use the calculator to solve these problems much more efficiently. So make sure you can get that and let me know. You're so quiet. So maybe you know this stuff. That's great. Let me know if you have any questions. I'm going to continue. So we have this is the basic formula then for a bond. It's a combination of the annuity formula and the basic time value of money formula, the discounted version. I even put the C1 in here rather than PMT, and sometimes I put the PMT in there. But my emphasis is to reduce your understanding to, it's basically a few formula. It's a few formula that we apply to different scenarios. Mathematically, that's what we're doing. So we have that formula. What if, so we focused exclusively on calculating the price this whole time, but what if instead, and this is much more realistic, we have the features of the bond and we want to compute the yield, because when bonds are trading in this secondary markets, they're not up from an initial offer, or they're not initially issued. Sorry, when they're initially issued, it's different than when they're selling in the market. The price can change. What if a bond is currently selling for this amount? It has these terms. The terms are 3% coupon with a face value of 1,000, and it matures in 5 years. So those are the features, but it's selling for $854.55. So you'll find listings of yields for bond selling in the market. So what's the yield? This is the timeline. To lay it out, remember the coupon rate of 3% is computed as a rate on top of the face value, so it's $30. So this is the timeline, 30, 30, 30, 30, 30, and the 1,000 at the end, and the price now. The price now is $854 that it's selling. What is the yield? What is the implicit interest rate, or the rate of return on that bond? The formula will help you compute it, but it's really hard to analytically solve this. It's even your calculator doesn't have a formula for it. The calculator will solve this iteratively. I think you might have learned how to do this with tables if you didn't use the calculator before, but look how lovely. If you haven't seen this before, now you're going to appreciate the financial calculator. So remembering that coupon bonds are the application where we use all the keys of the financial calculator, time value of money row. 5 is N. This is what we want to solve, right? So that's what we want to solve. We put the price in as a negative because we're going to, that's the value to be paid today, to receive $30 every period as your payment and a $1,000 face value at the end. Then you ask to compute FV. Now you will not, PV, what am I saying? Compute I by Y. I by Y. Not YR, but I have to edit that. Okay, and you will not get this answer unless you are cautious to have a negative as a PV and both of these as positives. You'll get an error unless you balance the equation. If you had the PV as a positive, then that would imply that you're receiving that amount, then you would have to pay these later. So from the side of the seller, this could be a positive, but then these would have to be negative. They have to have opposite signs on the equation, on either sides of the equation. The values have to be entered with opposite sign to the financial keys. So let me know. Do you get it? Are we good? Why is PV negative? Remember, the financial calculator operates with cash flows. To properly solve this equation, the calculator needs to know which of these cash flows are inflows and which are outflows. Okay? PV will be negative because you're being you're receiving, let's say you're the holder of the bond. That means you loaned out your money. How much you loaned out? $854.55 to receive $30 payment now and $1,000 payment in 5 years. Well, now and for the next 5 periods. And then $1,000 at the end of 5. So that's why it's a negative, because this is what you pay now in terms of cash flow to receive these cash flows later. Okay, so this is critical that you balance the sides of the equation with the signs, or you won't get the answer. You'll get an error statement from your calculator. Okay, so in our formula, we have looked at computing the present value. We just discussed computing the yield to maturity. The other variable that we could compute is the coupon rate. So here's an example. So on a bond certificate, you get the terms of the bond. You learn about the coupon rate. That's fixed. That's set. You learn about the face value. That's set. The term is set. So those are all predetermined. What varies then could be the price when you resell the bond. People consider it less or more or less valuable depending on what the bond, who sold the bond, whether that the bond issuer is good for their, you can count on them actually honoring the terms of the bond. So that's why we always talk about the yield, and we use a yield for bonds of comparable risk. So in this problem, the bond pays 1,005 years. Like I told you, my exercises will have $1,000 face value, so you can expect that. It's a 5-year bond. It's selling for $900, and you're told that bonds of comparable risk have about 8% yield. Now I'm asking you for something I didn't ask you before. Find the coupon rate. So in other words, what is the payment you're going to get every period with a yield of 8%? Since the price is $900 and the face value is $1,000, this is not a par bond. So let's see who can answer. Is the coupon rate going to be higher or lower than 8%? Since the bond is selling at a discount, this is a discount bond, it means that the coupons will not be sufficient to pay you the 8% yield. So that means the coupons rate must be less than 8%. Okay, so you should feel comfortable about that. Right, should be lower. So let's solve this. So at least, just when you read problems, think a little bit before you start the problem so that you're not surprised when you get an answer, or you recognize if the answer is wrong just by seeing an answer you didn't expect. Here you go. Let's put in the elements, the variables. So these numbers should already be in your calculator, right? So the N of 5, 8 now is the interest. 900 is the price. I put a negative because in this storyline, this is what it's worth, this is what I would pay, or somebody would pay for it, a prospective buyer. Payment is what we want to figure out. We don't know it. But we know the face value, 1,000, which we receive, so that's a positive. So it's an inflow. We asked to compute the payment. The payment turns out to be $54.95. Now we have to transfer that into a rate. Now remembering that we compute payments this way. Payment is the coupon rate times 1,000. So now that we know the payment, we can compute the rate by algebra. So yes, the C is less than 8%. It's 5.495. So let me allow you to do that. Ask me some questions. Don't forget, this is how you set up the formula. The most important thing here, if you're not grasping this, is understanding the difference between the rates. So the coupon rate helps you compute the payments you receive. And the yield to maturity is what you use as the implicit rate. So some of you may have heard this is called the market rate, or that's how you've been taught. Okay, the coupon rate is established. It doesn't change. The yield to maturity can change if it's the bond gets resold or it's on the market. And it depends on the other variables. So, these are all fixed. The duration, everything's fixed except for the yield to maturity. That can vary. And the price. The price and yield can change in the market depending on perceived value and the risk associated with the firm. Okay, you guys are quiet. I assume you get it. All right, so that's it. That's my introduction. These are all review or introduction for some of you and how to enter these into your calculator. And I have a last topic before I take a break. Annuities with growth. So we took a little break, a detour from annuities, and I returned to annuities. Angel can purchase an annuity to receive 30 years of supplemental pension payments beginning next month. These payments will be indexed for inflation. So they'll be adjusted for the fact that prices are going up by 0.2% per month. The prevailing interest rate is 0.5% per month. Okay, so that represents the market rate or the opportunity cost of $1. What is the present value of this annuity? So this is the timeline. This looks like a growing perpetuity, except that it stops. It ends. It ends at 360 months. So we don't have a formula for this yet. This is a very important formula. We don't have a formula for this yet. Let's derive it. Like I did before, first we begin with the growing annuity, perpetuity. The growing perpetuity looks like this. The price at time 0 is equal to the value of an amount to be received in one period that grows in subsequent periods. Remember, cash flow first, and then the growth kicks in. And this goes on forever. So I'm going to do the same thing I did to derive the annuity formula. I'm going to imagine the annuity this way. A growing annuity is a perpetuity that grows with the amounts after period T deleted or not paid. So I'm not going to receive these. So I need to value those that are coming. This is the value of those to be received in the future at time T, and I want to subtract them from the perpetuity. So I want to adjust the perpetuity, growing perpetuity, for these amounts I'm not going to get. I cannot, this amount here, I hope your eyes are not glazing over, stay with me. Now this is a formula. Let's look at this formula carefully. This is the annuity, sorry, this is the perpetuity formula with growth, with the first cash flow one period from T. So that's this one. So that's the first cash flow. That's why I have to write it this way, okay? And then I minus G is the, so this is the growing perpetuity. Growing perpetuity with the first cash flow one period from then is C1 1 plus GT. Don't let this bother you too much. You don't have to do this yourself. Well, I don't ask you to derive this formula, but you need to learn this technique. You're going to have to do and use this technique yourself for other problems. Okay, not every single problem falls perfectly into the, it doesn't align perfectly with the timelines I'm showing you and the corresponding formulas. You have to modify the formula, so you need to learn how to do that. All right, so you guys are with me. This represents the growing perpetuity starting at T. What I have to do is convert this into times $0. I do that using the basic time value of money adjustment. So I discount this back T periods. And then I need to take the growing perpetuity and subtract off these amounts, or this amount. So that is here. Very messy, right? No, I'm trying to do this as neat as possible. So what does that leave me? I can factor out my C1s, and I can factor out the denominator, and that leaves this adjustment factor in here. You see, so this looks familiar. Well, maybe not. I don't know. Maybe you never saw this before. This is the growing annuity formula. Very realistic. Applied in a lot of cases because within pensions, we talk about growing or indexing for the amounts to be received, the payments to be received, right? As a pensioner on fixed income, that's not so great. It's better to be compensated for the changing prices. This is also applied in problems of valuing stock because we will get information about a firm and its perspective, if it's going to grow or if it's going to decline. that will go into the growth rate factor. It helps us pricing stock with that kind of information. So here we go. This is the formula with a condition. You can only apply this formula if I equals G. What happens if I doesn't equal G? What happens if I equals G? What's the problem with that? I'll let you think about it. What is the problem if I equals G? Anyone? So if I equals G, this, you're going to get a 0 on the bottom here. That doesn't make sense. That's indeterminate. You can't solve that problem. Also, if I equals G, this numerator and denominator will be the same. So this will be 1. And so this will be 1 minus 1, which is 0. So you're just going to get 0 over 0, which makes no sense. So the formula does not work if I equals G. But does that mean that you can't have a situation where I equals G? Yes. Or you can have a situation where I equals G, but you can't use this formula. And I'll give you an example, right? So you can only use this formula for a growing annuity if I doesn't equal G. If I equals G, you have to go back to the timeline and solve the problem directly from the timeline. I'll show you how to do that when we get there. Okay, let's see if we can wrap this up. So this is the formula. I'm going to clean this up. Let me clean up my screen. Oops, that's too clean. I want to clean this up. Okay, so there's the formula that corresponds to this timeline. First cash flow 1 period from now, subsequent cash flows grow at the same rate G. So I'm going to illustrate again what I did yesterday. There's like a 1 here. So that means that growth starts a period after the first cash flow. Okay, so those are always going to have to be separated by 1. And this will go for T periods. So that's the timeline that corresponds to this formula that only applies if I doesn't equal G. What happens if I equals G? If I equals G, you're canceling the effect of the, perfectly canceling the effect of the erosion of the dollar by the prevailing interest rate, by the time value of money effect. So you're canceling, basically, it's offsetting the effect of interest or the effect of the erosion of the dollar. Let's deal with first the situation that the scenario that I set up for you. In the exercise, you were told about 3 years, so 360 months, with a prevailing rate of 0.5 and the growth of 0.2%. That's how you would write this. And there is no financial function programmed in your calculator to do this. you actually have to enter this. So I told you, you need to be able to know how to enter these as well as entering them into the financial keys. So how do we enter this? I'm going to recommend this for you, all right? Follow me here exactly as I do, and you won't be overwhelmed. So first of all, reduce this. This is, in your calculator, 0.003. So that makes that simple. Then start here. Take 1.002 divided by 1.005 equals. Then use y to the x 360. I'll do this a second time if you fall behind. Then change the sign to a negative and add 1. Oh, sorry. Yeah, I did that already. Okay. Add 1. What you've done with those steps is you've gotten this whole amount. And now it's simple. Say equals. Multiply by 100 and divide by 0.003. And that is it. So try that. Make sure you can get the answer I get, and then I'll continue. Let me know in the chat if you got it. I'll wait for about 5 people. Yes, there is a formula if I equals G. I'm going to show you an example, okay? It's another formula, but you need to modify it if it's not exactly with the timeline that I'm going to show you. Okay, you got it. I want 5 people to tell me they got it, and I will continue. Don't lie. Be honest. Okay, I'll say it again. Begin in the brackets, so inside. 1.002 divided by 1.005 equals. Then use the power y to the x 360 do you have to say equals? I'm going to double check. You guys got it. Did you get it using my method, or did you just do something else? 0.00. Okay, you got to press equals after this line. That's another equals. And then you change the sign, and then you add 1, and then you multiply by 100 and divide by 0.003. Now this computation used to take me forever, but that's what I use now to get me through it quicker. So you don't have to type this out in a long form on a programmable calculator or in Excel. It's actually, if you practice, it's very easy. And like I said, if you want to take the CFA exam, you're going to have to do it this way. So you might as well learn now. Okay, how many people said it? Okay, you got 5. 1, 2, 3, 4. One more. One more person. Okay, so make notes on your notes or take a screenshot. What I did here, this is page 75. This has to be computed in this manner manually because you do not have the formula pre-programmed in your calculator. But once you learn how to do it, it's not so bad. All right, perfect. Next. Okay, so what if I equals G? Here's an example. You're considering a deal where you will receive 100 cash flows for 4 months, starting next month. And each month thereafter, the cash flows will grow by 1%. What would you be willing to pay for such a deal if the effective monthly interest rate is 1%? So here's the catch. 1% interest with 1% growth. So you are being compensated with the growth to offset the interest rate. We can't apply that growing annuity formula. I mean, you could put these in you could simplify these and put them into your NPV function on your calculator, but that's not what I want to see. In an exam situation, I'm going to expect you to show me the formula, right? Well, I guess you could write an NPV formula, but I guess I should specify I want you to show me the annuity formulas for this. So to use the annuity formula, well, you wouldn't be able to, right? Because I is equal to G. So we have to go back to first principles, where the formula came from. It came from thinking that I'm going to discount each amount. The first one, 1 period. The second one, 2 periods. The third one, 3 periods, and so on. Notice what happens. So this is this amount, 1 period, 2 periods. This amount gets discounted 3 periods, and this one 4 periods. So what do we see here? Let me make this a little bigger. So this is my first amount. Everything has been discounted to now. So I can actually add and subtract these amounts. In this case, add them, right? So these are my discounted amounts that I could sum, just like NPV would. There are 2 here, so I could cancel that with that. And there's 3 here, so I can cancel 2 of those with that. And then on the lower one that maybe you can't see, there's 4 here, so I'm going to cancel with 3 of those. And what does that leave me? It leaves me exactly the same amount, because the growth is offsetting the erosion factor of the interest, okay, of the opportunity cost of $1. So I have 4. They're exactly the same amount because of this offsetting effect of growth against the interest or the discount factor. So if you have this scenario, my recommendation is that you draw the timeline and you figure out the pattern. In this particular instance, all you had to do was multiply by 4 to get the answer. You would need to get the first amount, which is this one, and realize that all the other amounts will be the same. So there's just a total of 4, and that would be the value, $396.04. Okay? All right, let me let you stare at that for a bit, and then I'll get on to the last few slides. Let me know if you have any questions. Okay, so this timeline was very specific with a payment, one period from now, and then growth that continues. And then the growth factor, the growth rate, was the same as the interest rate, so they canceled. And so since there were 4 total payments, all you did was the number of payments. So you can make a formula for yourself, the number of payments times the first payment divided by 1 plus I. But I prefer to just tell you, if you don't have a scenario that perfectly matches the timelines I've given you in the formula sheet, that you have to adjust it, and you do that from first principles, and you see how things cancel out. All right. Now we're going to put several things together. You know, I need to take a 5-minute break. Let's take a 5-minute break, and then we will go through this. So I'm going to pause for 5 minutes, and we're going to pick it up here. You can use the washroom or get a drink. I'll be right back. You can send me questions in the chat too. All right, I'm back. Okay, so this is the last of the exercises for now. And then after this, we're going to get into interest rate conversion. So I'm going to send you a bunch of documents for that. So here is the pension problem. Paying $3,000 per year for 30 years into a fund, earning 12% per year. The first payment in 1 year. Okay, so payments are yearly. You're going to be, well, if this is you, you're going to be paying $3,000 into a fund that's going to accumulate. All right, and the rate is 12%. And then, so this is, the timeline is from the perspective of the fund. So let's speak in perspective of the fund. So the fund, the cash flows into the fund would be then, so I'll say it in the reverse, will be $3,000 at the end of each year till the 30th year. And then the contributor retires and begins to receive payments for 20 years starting 1 year after. So the question is, how much can this person withdraw? This is going to put together all your knowledge of of annuities, really. These are annuities, right? You got an annuity over here, and then you have annuity over here, and I'm taking it back to the period where you want to value it. So what you want to figure out is, for this annuity here, begins at 30 with the initial payment starting 1 period from 30, right? That's how the formulas that I taught you work. So for the initial payment to start 1 period from 30 or 31 and to continue at the same amount for 20 years. So there's a timeline. So I expect you to draw that timeline. How am I going to figure this out? This is what I need to get this. However, where does this come from? This comes from an accumulation of these inflows to the fund for 30 years. All right, so you have an annuity formula that would give you the PV zeros of the inflows here, but that's not what I'm interested in for this problem. I actually want the FV30. I want the value here. So I want the value of these amounts accumulating to the future value amount. Now we haven't done that yet, but that is, well, we have talked about future value in terms of the time value of money formula, but I haven't shown you how you can get the future value of an annuity. So we're going to talk about that. And it's all it is a matter of putting the time value of money formula together with the annuity. Okay, and we're just combining formula. So then that amount should be the same as what's in the fund from which you can withdraw, or the contributor can withdraw. So let's see if I can lay this out. So the cash flows into the fund are an annuity like this. So there's my regular annuity formula. So let's begin. Calculate this amount and confirm you got it. I want to see 3 people say they got it, and then I'll continue. So first step. So you're using the 12% for 30 periods of deposits or contributions. Contributions of the size 3,000. Anyone? Nobody got it yet? All I want you to get is the first part. No one? Okay, somebody got it. Okay, the first part. Okay, so 3 people got it. Perfect. So I'm going to move on. So that's the first part. Now, as I say here, I really want the future value of that amount. So I have an amount here that you guys calculated the PV of 0 of just this part, the inflows. But what you want is to accumulate it as though it was the future value. You want the future value representation of the value today. So what that at an interest rate of 12%, that would accumulate to this amount. Okay, so all I want you to do now, if you put these into your calculator, now I want you to do this using the keys. So here's step 1 with the financial keys. All you need to do to get the future value, rather than asking for PV, put 0 in PV and ask for FV. No, you're not going to do that. Okay, so someone asked, how do you put the exponent? I don't want you to do the exponent. I want you to use the financial keys. But if you want to put the exponent, it's y to the x. But I don't want you to use the exponent. I want you to use the financial key. So back to the financial key. So see, the only time you need to actually calculate manually is when I ask you to, or for growing annuities. Otherwise, you just use the calculator, financial keys. So the time value of money keys, that's it. Again, you have to write the formula out, but then to find your answer, you use the financial key. So rather than asking for PV, it's very simple to ask for FV. Now, what is the calculator doing to get that? The calculator is doing this. It's putting an accumulation factor with a basic time value of money, right? Accumulating for the future value 30 periods at 1.12. So you can do this manually, but it's much faster if you start training yourself to use a financial calculator. Questions? Since this problem has 2 parts, I'm going to take advantage of the storage keys. I'm going to store that value in my storage slot 1. Now that amount is what I have in the future, $723,998.05 to draw from. How do I draw from that? Well, the future value of these amounts, so the future value of contribution I need to make this bigger. The future value of contribution is the same as the present value at time 30 of the fund. Okay, so I'm going to make these contributions and then I'm going to accumulate a fund from which to draw money. So the next part or step is to talk about those withdrawals. The withdrawals are here. So now I call it PV30. So FV30 becomes PV30. Present value of 30 is the amount of the fund from which I withdraw payment. This is another annuity. You have to write the formula out and then solve it with the financial keys. Asking for payment. So everything we've reviewed with the calculator permits you to do this exercise very efficiently. Now with withdrawals are only 20 periods, same rate, using the PV that you stored as FV in storage 1. So recall 1, put that into PV. Future value is not of interest, make it 0, and ask for the payment, and you will get the payment amount. If you enter PV as a positive from here, then your payment will come out negative. And you know that that is the payment amount. I don't know why I said this. Okay, so this is not the PV, it's the payment. That's funny. So this amount, so what's happening? You invest $3,000 every month for 30 years, and that accumulates to $723,000, almost $724,000. And then, because the contributions have accumulated to that amount, and they will continue to accumulate, right? The fund continues to accumulate, but you want to withdraw from that fund that continues to accumulate an amount and reduce the fund to 0 after 20 years. That's all taken care of in this formula. All of that information is accounted for in this formula. So I need to really fix this because this is not what it is. That's just the payment. So what you're trying to figure out then is how much can you withdraw every year for 20 years? Once a year. Is that what we did? No, we did $3,000 every year for 30 years. Well, that's a lot, right? It's not 30 times 3,000, that's for sure. It's a lot of money. Accumulating to $723,998 because of the 12% rate and the compounded interest effect. So that becomes almost $724,000. Now I want to figure out how much can I withdraw. Do I just divide that by 20? No, I don't just divide this by 20. That's a fund, and that fund keeps earning interest. When I take out a bit, the remaining continues to earn interest. So it's not just a matter of dividing by 20. I need to take account of the time value of money effect and use the annuity formula to solve this. Using the financial calculator, it'll account for all those pieces of information, and it will compute that you can withdraw $96,000 a year at the end of each year, because we assumed it's at the end of the period. All right? That's a lot of money. That's a lot of money. All right, so that's the effect of compound interest. Any questions? I'll just have to clean that up because this is not the present value of the investment. This is the amount you can withdraw. The present value of the investment was $24,000. So the key to understanding this is, well, there's a few things. One, the amount you accumulate in the first part continues to accumulate while you withdraw amounts. You're withdrawing for a shorter period, so they're going to be larger amounts than you deposited. And because it's a large amount, it continues to earn 12%, you can withdraw as much as $96,000 a year for 20 years. Okay, let me know if you have any questions. Any questions? No comments? No questions? The formulas are there. You have to put all the formulas. So for this problem, you have the cash flows in formulas, and then you have to do two steps. First, the present value, and then the adjustment to the future value that you want to use. And then this is the formula. So you have to write 3 formulas. You can combine these two, but it gets really big and messy. It's up to you. But I see 3 formula. Okay, they are the annuity formulas. And here it's adjustment. So that's what you have to write. And then at each stage, you can solve using your financial calculator. All right, so if you don't completely get it, just remember what we did and go back when you see problems like this where you're accumulating a fund and then withdrawing. There's 2 steps, there's 2 parts. There's the inflows and then there's the withdrawals. Both are accumulating, and that's why you have to use the annuity formulas. Okay, so don't worry about it too much. We're going to practice with that. Can 3 people show me they got the final value? Send me a message. The final result is the $96,927.98. You should have exactly my numbers to 2 decimal places. As you see in the exercise I sent for homework, for practice, which I'll send you the solutions today, I give you instructions. I need the answers to 2 decimal places for dollars, and I need the answers to 4 or 5 or 6 decimal places for percentages, okay? But in between, you have to keep all the decimal places. You have to store all of the values. So even though here I wrote this amount 0.05, there's many decimal places after that that I used in storage. If you just copied this number and put it in here as the PV, you're not going to get exactly my answer. And if you do that, I will have to withdraw, or I will reduce some of the points. I'll take some points off if you don't have exactly my numbers. Okay, some people got it. Okay, so that takes practice. Practice makes perfect. Perfect practice makes more perfect. Let me know if you need help with that. So we're going to take a little breather from the problems and talk about technique. This is another tool for you, what I'm going to show you now. You're going to have a variety of exercises to solve with time value of money, and you need to be clear about a couple of things. Counting intervals and counting payments, they're different. For instance, how many periods of interest or how many periods of growth are there between the end of period 18 and the end of period 55? So remembering the first class how I explained, these tick marks will always denote the end of period. So 18 means end of period 18. 1 means end of period 1. 55 on the tick mark means end of period 55. So the question is, how many periods, how many intervals, periods of interest or growth, so intervals, how many intervals are there between 18 and 55? How are you going to figure that out? And I suggest look at your fingers. So if you ever forget how the heck to do this, well, maybe you know the answer. Maybe you know what to do. What is the answer? How many periods are there between 18 and 55? Let's assess how challenging this is. How many periods of interest between 18 and 55? Assuming there's a set rate of interest that doesn't change. Or even if it changes, how many periods of interest between 18 and 55? But nobody knows. All right. So it's not that straightforward. Okay, Alex says 37. Okay, you guys, okay, now it's a little bit confusion, 36. How do you figure that out? Okay, so how you figure it out, look at your fingers. Let's say I want to know, there's 5 fingers on your hand. If you numbered them 1 through 5, there's spaces between the fingers. Even though there's 5 fingers, even though there's 5 tick marks, there's how many intervals on your hand? How many spaces between the fingers? How many spaces between the fingers of your hand? That's the equivalent of what we're looking at. So the spaces are 4, right? But you have 5 fingers. So to actually know that without looking, it's 5, right? So if you numbered your fingers, the last one would be 5 and the first one would be 1. You're taking the last one minus the first one to get 4. It's the same thing with intervals. You take the end of the last one minus the end of the first one, and that'll tell you how many intervals. So anyone who said 37 is correct. So, what are the number of intervals between the end of period 1 and the end of period 5? That was the question that you answer on your hand. That would have been 4, right? You just subtract. So in our case, it's 37 because you take the 55 minus the 18. So that subtraction is calculating intervals between. If you want to know how many payments there were between 18 and 55 inclusive, that's different. Okay, Brenda's supposing something else. No, Brenda, I'm just saying there's interest all through here, and I'm just interested in 18 to 55. So there's interest in all of them. Okay? So yes, I'm going to start jumping from period 0. I'm going to talk about the whole timeline, any place in the timeline. That's what we're going to head towards next. But before we do that, we're going to do the interest rate conversions. Okay, so if you want in between, if you want intervals, it's last minus the first. You can do it from the end to the end or the beginning to the beginning. Again, we're not going to work with beginning of period too much, but you need to know if you're going to calculate intervals from the beginning of a period, you have to go to the beginning of a period. All right. So that's how that works. So let's see how that's different. What if you want payments, the number of payments? So there's payments to be made for 55 periods. How many payments are there between? Okay, now I switch it up. The beginning of the 19th period and the end of the 15th period inclusive. So the beginning of the 19th, is where? So we have to do all this translation, right? So the beginning of the 19th is the same as the end of the 18th. Remember that discussion we had yesterday at the beginning of the class. The end of the 18th is the same as the start of the new one, the 19th. So I'm asking you now how many payments beginning on the 18th and going to the end of the 55th inclusive. So what I'm saying is how many tick marks between here and here. That's different than intervals. So intervals is just last minus first. Payments is going to be last minus first plus 1. There's 38 payments because you have to count all of the tick marks. Again, back to your hand. Look at your hand. How many fingers between the first and the last one? How many fingers between the first and the last one? There's 5 fingers. You have to add 1 back. Okay, so when you subtract from end to end, you have to add 1 in because all that's doing is counting intervals. Right, 38. Very good. You guys are good. Okay, so intervals, last minus first. Payments, last minus first plus 1. All right? If that ever comes up, if you ever need to know. And then we get to interest rate conversions. All right. I'm going to send you, give me 5 minutes, I'm going to send you some exercises for review. You guys can think about this, ask me some questions. I'm going to take 5 minutes to send you some exercises for review. Okay. Okay, I'm back. So here's some problems. I emailed them to you, so you have them. I'll send you the solutions tomorrow. For now, let's work on a few of these. We have. Let's try for another half hour. So there are 4 problems. Well, 3 problems. Okay, 3 methods. Okay, so let's see. Why don't you try these and I'll check back in 10 minutes. All right, I'm gonna give you 10 minutes. I'm gonna come back. Well, the thing is there's a delay for us, so it'll be around 11:24. So we'll check back at 11:24. You can ask me in the chat if you have questions, okay? So you don't just wait for me. 10 minutes. Okay, I'm back. Each time I go, I lose viewers. So, here we are. I want you to use the annuity formulas for these exercises because it seems that you could use NPV formula, but that's not what I want you to do. I want you to specialize in the simplifications, okay? So, we're going to make a timeline. You receive 1,000, or to receive 1,000 for 5 years, starting 4 years from today. So if today is 0, let's see if I have these nicely drawn up, typed up to share with you later, but let's make our own, for now, timeline. So I have 4 years from today. So 4 years from today would be 1, 2, 3, 4. So when I count from now, it corresponds to the number that I put here. So this will be 4 years from today. And you receive for 5 years. So let's make this a little smaller so it can fit. This is something I cannot do with a chalkboard. So this goes on. So 1, 2. So for 4 years, starting 4 years from today, receive 1,000. So I receive 1,000, and then 1,000 for 5 years. That's it. This is what you should have drawn. Okay, maybe nicer than mine. Okay, that's all we're told. But we want the present value now of this amount. I gave you a bunch of formula. Those formulas are all for period now calculation, not for something going on in the future. So we have to adjust those formulas using some of the techniques I've already showed you or you're familiar with. The annuity corresponding to our formula would be here. It would start one period before the first payment. So if I use the formula, I would just get PV3. Let's put the numbers on all of these. So I would get the value one period before the first payment. Remember, that's what the formula gives me. So I could figure that out, but that's not the answer. The next thing I have to do is discount it back to find the present value of that amount. So there's 2 steps. 1, apply the formulas that I've given you in the timeline specifically. Okay, so I go right into the timeline and I apply the formula. Then I adjust. I adjust the formula so that it's where I want the value. You have to express all the formulas I told you, right, for a test situation. So you got to put a formula here, you have to put a formula here, but then you can just use your financial calculator to punch it all in. How many of you can actually get this answer? Let me know. Go ahead and try it. Write up the formulas and then use your financial keys. Use your financial keys, please. So I'll just start writing the formulas out. So PV3 so hard to do this. So I need to find what is the rate is. It's 8%. Give me a second. Okay. So this was for 8%, right? So this is 1.08. And then I want to do this for 5 periods. So that's that discount factor. And then 0.08 here. So that's the formula for that, which I can plug into my calculator with N with 5 and N. PV is what I want. Interest is 8. PV is what we're going to get later. 1,000 into PMT. And 0 into FV. And then compute PV. And you will get the first part. So what do you get for the first part, PV3? Anyone? Don't resist using the financial keys. They should be used in tandem with the formula. But you need to practice, and you only have 3 weeks to become efficient at it. So start practicing now. So I used 1,000 because I'm receiving 1,000. Aha, you got an answer for me? I'm going to confirm it. Very good. Okay, so now there are a bunch of decimal places there, but you're going to write here just for yourself, for me, to know that, you know, it's really good to show me your work. It's really important that you show your work. So it's going to be, don't put the negative in there, just 399.710037. Now, I don't expect you to write all the decimal places out, but don't delete them either. Okay, we need to have the same answers. So what you're going to do with that number is store it. Okay, so we're going to put that in, store 1. So that's on your screen. Then say store 1 and make a note on your, oh wait, we have to make it a positive first. Make it a positive first. Make it a positive first. And then store 1. So it's all the decimal places are stored. Okay, all the decimal places are stored. Do not round this amount. So now that's in there, let's go back to what we have to do next. Now what we need to do is take that amount and discount it back to times 0. Now it's in your calculator, it's stored there. all we have to do is, to find PV0, I'm going to make a note. What I have to do is equals PV3 discounted, right? Because it's a lump sum. I'm going to use the basic time value of money, 1.08 for 3 periods. Remembering that these numbers will take me back to 0. Right? So 3 periods, discounting up an item that's at period 3 will take me back to 0. So you write that formula out. So writing all that out is what I want. I really want to see the formulas and then the answer. So how would we put this, how would we get the answer? Now you can do this in your calculator using manual, but why don't we enter this in using the time value of money keys? How would you do that? Well, let's write that up. Let's see if I'm going to make this bigger. So how do I put that in? Well, it's just n is 3. Let me use, I don't know, black. So I'm going to put 3 into n. That's not enough room, is it? I need way more room than that. Let's make this bigger. I'm just going to use the whole thing. It's amazing. Okay, so put that in to find the future value, the present value at time 0. So notice this looks weird, right? You probably feel like, oh, that's weird. Why is she writing PV there? Or maybe you've never seen that before. Remember, future value and present value is just a perspective. Present value at time 3 is the same as future value at time 3. So I can't put it there. They're the same. So I'm going to write, so 3 goes into n, and then 8 goes into, it's already there, into I. And then PV is what I want, so I'll wait for that. And then I'm going to say, there's no payment, right? So 0 goes into payment because now this is a basic time value of money problem. And future value is recall 1 and put that into the future value slot. You guys can see that? And then compute PV, and you should get the answer that's in brackets at the top. So this is how I want you to answer questions. You don't have to show me these calculations, these data entries into your calculator, but you might want to write them out for yourself. I'm writing them out for instructional purposes right now. Okay, so that's just a reminder. It's going to shrink, but that's just a reminder of how to do that. If you don't want to do all that and all you want to do is divide by 1.08 to the power of 3 using y to the x, you can do that too. I won't stop you, but I do want you to practice using the financial function. I'll show you some other tricks as we go. Your answer should be 3169, which I'll write here. So the answer is PV0 is equal to 3,169. Now you can round it, now that we're done. 69 and 54 cents. Never round intermediate calculations. So, recap. make a timeline. You make a timeline and you apply the formula where the timeline demonstrates the formula applies. It only applies here with 5 payments starting at time 3, 1 period from time 3 begin the payments. So I can figure out the present value of those, store the result, and then use it as the future value in a discounted problem to get the final answer. This kind of thing is what you're expected to do in this course. If you're having trouble with this, let me know, okay? You got to be good at this. All right, it is 11:38. Should I do another one? Do I have time? I'll just do the timeline with you for the second one. Can I start the second one? Yeah, I'll give you a couple minutes, draw the timeline, and then I'll show you what I get for the timeline, and I'll give you a suggestion of how to solve it. And then tomorrow, well, you can work on it tonight. There's also a third problem here in the sheet. And then we'll look at it tomorrow. I'll send you the clave tomorrow as well. So, you know, I make a mess in doing this problem on the pad, but I have the worked out solutions all typed up, neat and tidy. But you can reference these videos to remember what I did. Again, I want you to use annuities for this problem, right? Looks like this could be done easily with net present value, but I want you to use annuities, the 2 annuity cash flows. So, oh, I put way too many in here, didn't I? 3. I have way too many years. Okay, let's do this again. I got carried away with my timeline. So I just want I want 6. So 2,000 for 3 years. And then 3,000 for 2. So it ends here. I don't even need the 6th year. All right. So what I have here, I call it the 2 annuity case. You have this annuity here. And then you have this annuity here. So I can call it A and B, or just follow carefully, see what I'm doing. So this is an annuity because the first cash flow begins 1 period from now and goes for 3 years. So it's a 3-year annuity with a rate. The rate is the same throughout, always at 10%. So, you know, an annuity, you can buy an annuity, pay something today to receive something later. So here it comes back at you, $2,000 for 3 years, which you can calculate. We'll call this part A. And then there's $3,000 for 2 years. So 1 period before that, part B is at time 3. So what you've got to do is calculate the present value for the first part, and then for the second part, you need to compute the present value at time 3 and then discount it back to time 0. And add those together. So those are the steps involved with that exercise. Okay, so it's like 3 steps. You get A, you get B, that's 2, and then the third part is discount, and then sum is the final part. So like 4 parts. If you did this on exam, you would draw the timeline. You would write out the result. It's 10%. Correct? It's 10%. And then for part B, it's 3,000 for 2 years. So whatever you get there, this is a 0, right? Whatever you get there, then you discount that and put it here. So get an answer here and you can put it in store 1. Get an answer here and put it in store 2. Then discount it and you will get store 3, and your final answer will be store 1 plus store 3. So that is the outline for how you're going to solve that. I want you to practice that. Okay, I'm going to let you guys go. You're going to practice that, and tomorrow you're going to ask me questions. You're going to completely solve this problem and this problem. Why? Oh, here's the example here. So this one here. Now this is applying the annuity due formula. Okay, so I want you to solve all these problems for tomorrow, and we'll pick up discussing them. And then any questions that you have on the review that I sent. I'll send you another review with solutions from the first one today. And we just got to keep moving. You got to keep studying. And I would say you need at least 3 hours a day after class working on these problems. If you can use less and you still cover the material, great. If you need more and you're running out of time, let me know, so we'll see if there's some misunderstanding that I can help you with. All right, so I'm gonna say goodbye for now. Let me know if you have questions. Yes, I'm gonna send the solutions for the first one. No problemo. Okay, let me know if you have any questions. You can put them in the chat. I'll leave the chat up a little bit after I sign off. Okay, bye-bye.